Question 1, write 36 as a product of its prime factors. Well, this is the number tree, so break 36 down into two of its factors, doesn't matter which. So for example, 6 times 6 is 36, and then is 6 a prime number? No, it isn't, so you carry on with the number tree. How do we make 6 with factors? Well, it's 2 times 3, also with the other 6, 2 times 3. These are all prime numbers, so we circle those. Now our final answer is a product, so that means being multiplied together, so you must remember to put in the time signs, and then it's just nice to make it numerical order, but you don't have to. So 2 times 2 times 3 times 3, and obviously when you multiply those together you get back to your 36. Question 2. So we're going to construct and solve an equation here. So make x equal to the smallest bit of information. So we're told that Kira is 7 years older than J. So J's the youngest, so let's go and let J be x years old. So Kira is 7 years older, so whatever J is, whatever this unknown number is, we add 7 onto it to get Kiara's age. And then thirdly, we're told that Martha is twice as old as Kiara. So be careful, it's twice as old as she is. So it's 2 lots of the x plus 7. Now what are we told about these three? We're told that the sum of their 3 ages is 77. So when we add J's and Kiara's and Martha's ages together, this equals 77. So x plus 7 plus 2 lots of x plus 7 equals 77. Expand the brackets, we get 2x plus 14 here. Gather up like terms, so gather our x's, we get 4x. Gather our normal numbers on the left, we get 21, and that's equaling 77. Take away 26 from both sides, then divide. Question 3, we've got to show that angle ABF equals 70. So this is ABF, A to B to F. We've got to show that this is 70, and we've got to give a reason for each stage of your working. So first things first, this angle here, AFB, is also 35 because vertically opposite angles are equal. Now once we know this is 35, we're just really focusing on this triangle now. So what can we say about this angle here, this angle BAF? Well, this is part of a parallelogram, and opposite angles in a parallelogram are equal. So we can say this angle BAF is also 75 because opposite angles of a parallelogram are equal. Now once we know that, we've got we can say that this is 70 because angles in a triangle add up to 180, so 180 minus 75 minus 35 equals 70. Actually thinking about what I should probably have written down here is that is to actually justify why I've done this. So I should have put in, because we've got to give a reason for each stage of your working, make sure you also write down here that angles in a triangle total 180 degrees. Question 4, so we're being asked to see whether exactly a third of the total logo is shaded. So let's start off by working out the total area of the whole logo. So that's really the area with the biggest circle. Well, that has got a radius of 10, 4 and 3 and 3. So the area of the whole logo is pi r squared, pi times the radius squared, pi times 10 squared, which is 100 pi. Now, to work out the area of the shaded bit, I'm going to work out the area as if it was completely shaded, the inner two circles. So we're going to work out the area when the radius is 7, and then take away from that the white bit in the middle when the radius is 4. So starting off working out the area of the two inner circles, that's when the radius is 7, we've got pi r squared, pi times 7 squared, which is 49 pi, but the area of when the radius is 4, pi r squared is pi 4 squared, is 16 pi. So the area of the shaded bit is the area of the 7 centimeter radius circle, take away the area of the 4 centimeter radius circle, 49 pi, take away 16 pi, which is 33 pi. So the proportion of the total logo which is shaded is 33 pi out of 100 pi, which is 33 over 100. Now that's near. Question 5, so we need to work out an estimate for the mean of the weekly earnings. Well, it's an estimate because we don't know how much these people actually earned. We just know, for example, that this one person earned between 150 and 250 and so on. So we estimate by choosing to assume this person earns the midpoint, so earns halfway between 150 and 250, which is 200. So I need to start off by working out all the midpoints. So we can just see this by sight, it's just halfway between the two. And from then onwards we assume that's exactly how much all these people earned. So one person earned £200 a week, which is 200. 11 people earned 300, which is 3,300, and so on. This gives us a total amount of money earned in a week of 7,300. Divide that across the 20 people. Be careful, don't divide by the 5 rows, divide by the 20 people, and that gives us £365 being an estimate for the mean of the weekly earnings. Now, Nadia says the mean may not be the best average to use to represent this information. Do you agree with her? Well, she may or she may not be right, and I think we just really need to remember all the pros and cons of the various averages. And the downside of the mean is if you've got a really big value or a really small value to really distort the data. So if you have an outlier. So I think the best thing to say is Nadia may be correct, as outliers can distort the mean. Question 6. So we're being asked to show that y equals 3. Well, y is the base of this rectangle. And what else are we told? Well, we're told that the area of the rectangle is 48. So a rectangle's area is base times height. So really, to get to the bottom of this, we're going to need to start off by working out what the height of this rectangle is. And we're told two pieces of information about the height of the rectangle. On the one hand it is 2x plus 6, but on the other hand it is 5x minus 9. Now clearly these two sides are equal, so we can solve 2x plus 6 equaling 5x minus 9. So that's what I've done over here. So let's take away 2x from both sides, giving us this. Then add 9 to both sides, we get 15 equals 3x. Divide through by 3, we get x equaling 5. So x is 5, so I can work out the height of the rectangle by substituting x being 5 into either of these two equations. Let's substitute it in this one, for example. 2 5s are 10, 10 add 6 is 16. So the height of the rectangle is 16. We need to show that the base is 3, but the area. Question 7. Write down one thing that is wrong with this graph. Well, this shouldn't just be jagged straight lines joining this. This line needs to be a nice gentle curve. So the line should be a curve, not line segments. Question 8. So to compare and contrast these, let's just write out what each of these is in sort of a longer form. So here we've got the 4 and the 6 recurring repeatedly, so that's 2.46, 46, 46 and what have you. With this one we've just got the 6 recurring, so we've got 0.24666666 and so on. And with this one we've got the 246 all recurring, so 246, 246, 246. And here we've obviously got nothing recurring. So smallest to biggest, this is the smallest one, just being 0.246 on its own. This is the next smallest, as after the 246 we have a 2. Then this one, because after the 246 we have a 4. And then finally this one, because after the 246 we have a 6. So that's the order 1, 2, 3, 4. So just write down 1, then 2, then 3, then 4. Question 9. Now these take a bit of thinking about, so just really try and break the information down and work your way through it in a logical order. So let's start off with James's information. We're told that he took 2.5 hours to cycle the 50 kilometers. So what I really want to do, because they catch up, Peter catches up with James when they've both cycled 15 kilometers. I really want to know how long it took James to cycle 15 kilometers. So let's focus on that. So I've started off by dividing by 2.5 to get back to how far he would go in 1 hour. So 20 kilometers would be in 1 hour. So 15 kilometers, which is 3/4 of 20, would take me 3/4 of an hour, which is 45 minutes. So James takes 45 minutes to go the 15 kilometers to when Peter catches up with him. So let's move over to Peter then. So Peter, how long does it take him to travel the same 15 kilometers? Well, he started cycling 5 minutes after James started to cycle. So as James took 45 minutes, Peter took 40 minutes. So Peter travelled 15 kilometers in 40 minutes. We need to change this into a speed, into kilometers per hour. So we need to apportion this up to get 60 minutes worth. So what I've done, I've chosen to question 10. So to the power of half just means the square root. So what's the square root of 100? Well, that's 10, because 10 tens are 100. Now the power of 2/3 means two things. First of all, we need to cube root the number, and then secondly we need to square it. You could do it the other way around. You could square then cube root, but that's much trickier. So we're going to cube root first and then square. So the cube root of 125. What number times itself then times itself again gives us 125? That's 5. So the cube root of 125 is 5. So that's the cube root. But secondly, we need to square this. So it's 5 squared, which is 25. Question 11. Well, hopefully you can just spot that this is a simultaneous equation in words. So we've got 3 teas plus 2 coffees equaling £7.80, and also 5 teas plus 4 coffees equaling £14.20. Let's call these equations 1 and 2. So I need to line something up, either the C's or the T's. So I'm going to choose to double this first equation. so that I end up with 4c's, then I can eliminate the 4c's. So doubling everything in equation 1, I get 6t plus 4c equals £15.60. Now if I then align that with my equation 2, my 5t plus 4c equals £14.20, I can now eliminate the 4c's if I choose to subtract the bottom equation from the top. So 6t take question 12. So I have to draw this information onto the box plot. So 154 is my lowest value. My lower quarter value, which is where the rectangle commences, is at 161. The median, which is the line inside the rectangle, is at 165. Now to work out the upper quartile, I know that the upper quartile take away the lower quartile is the interquartile range. So the upper quartile must be 161, add the 7, which is 168. So my upper quartile, where my rectangle finishes, is at 168. And then my highest value, I also need to work out the greatest height. So that's going to be worked out from the fact that I know the range is 20. The range is the difference between the greatest height and the least height, so which is 20. So my greatest height must be 154, add 20, which is 174. So apologies, these lines are so sort of scruffy. This upper line should be like this. It shouldn't have this bit going beyond it, so sorry about that. The actual height of this box plot doesn't matter, so the height doesn't matter. So just to clarify, we've got the lowest height, lower quartile. Question 13. So we're told that on Monday Milo calculated that he needed exactly 4 chicken pies in his sample. So 4 out of 15 in his sample. So we need to have the same ratio as we have in the sample as in the population. So we have 450 pies in total. So 4 over 15 is going to be x over 450. How do we get from 15 to 450? We multiply by 30. So 30 times 4 is 120. Now on Tuesday, the number of steak pies Milo needs in his sample is 6 correct, the nearest whole number. So Milo takes at random a pie from the 450, work out the lower bound of the probability that the pie is a steak pie. So looking at this sample proportion, the lower bound is 5.5. 5.5 is the lower bound of 6 correct, the nearest whole number. So it's going to be 5.5 out of 15. Again, then following this proportion through to the population where we're choosing out of 450, again we're multiplying by 30. 5.5 times 30 is 165. I've done that by doing 5 lots of 30, which is 150, then half a lot of 30, which is 15. 150 at 15 is 165. So the lower bound of the probability that the pie is a steak pie is 165 out of 450. Question 14. So we're told the ratio of this to this is equivalent to this, and we have to show something. Now, the hardest bit here is this first line of working. So I've just done a simple version just to help me explain. So here we've got 2 equivalent ratios. For example, 4 to 6 is equivalent to 2 to 3. Now if I go and pop these ratios on top of each other, so there's your 4 to 6, and divide through by the 2 to 3, they are now equal to each other, because 4 over 2 is 2 and 6 over 3 is 2. So if I just divide one equivalent ratio by the other, they then become equal to each other. So I can say that y plus x to y minus x, excuse me, divided by k to 1, they equal each other. So once you've got this far, this is fairly straightforward. So it's just how do we undo a dividing by 1? We multiply by 1. How do we undo a dividing by k? We multiply by k. So let's multiply through by k. So we get y plus x equaling k times y minus x. Multiply out the bracket, we get this. So I want to make y the subject, so I want to get all my y's on one side, all my terms without y on the other. So to keep things as positive as I can, I've taken all my y's to the right hand side. So I've minused y from both sides and added kx to both sides, giving me this. I've then factorised both sides, so here I get an x bracket k plus 1, and here I get a y bracket k minus 1. Divide through by k minus 1, I get y equaling x times k plus 1 over k minus 1, which is what I had to show. Question 15, so we've got to prove this algebraically. So start off by letting x equal this, but write it out sort of dot 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 format. So x equals 0.436363636 dot dot dot. Now because we've got the two dots, choose to multiply through by 100. So 100x equals, and obviously all of these numbers move over 2. So we get 43.6363636 and so on. And you'll see that once we've gone past the first decimal place, our decimals now line up. So if we call this equation 1, this equation 2, and we subtract 1 from 2, we get 99x equaling 43.2. Now I want to try and avoid having a decimal amongst a fraction. So at this point I'm choosing to multiply through by 10. Then I am dividing through by 990, giving me x equaling 432 over 990. And then I just have to simplify the fraction down until I get to my 24 over 55. Question 16. So very much a set process you follow on one of these. As y is directly proportional to the cube root of x, your provisional formula is going to be y equaling k times the cube root of x. Had it been is inversely proportional, it would have been k over the cube root of x. But as it's directly proportional, it's k times the cube root of x. Now, they're now going to give you an x and a y to allow you to work out what k is. So they've told us when y is 1 1/6, which is 7/6, x equals 8. So we substitute these both in. And so we've got 7/6 equals k times the cube root of 8. Now the cube root of 8 is 2. So 7/6 equals 2k. Divide through by 2, we get k equaling 7/12. So we can now improve on our original formula and have a revised formula where we now know that the constant k is 7/12. So our final formula which we can use is y equals 7/12 times the cube root of x. Now only now do we take this line of information and actually answer the question. Find the value of y when x is 64. So y equals 7/12 times the cube root of 64. The cube root of 64 is 4, because 4 times 4 times 4 is 64. So y equals 7/12 times 4. So that is 28/12, which is 14/6, which is 7/3. Question 17. So prove algebraically that the sum of these two is always a square number. So quite simply, you're just going to add these two together, follow through the algebra, and hope you come out with something which is squared. So let's do that. So adding the two together, so that's my first line of working. So let's multiply out this first bracket. So we've got a half n squared plus a half n. And with this one, I'm just starting off by multiplying out the pair of brackets, which gives me n squared plus 3n plus 2. I've then multiplied each of those by a half to get a half n squared plus 3/2n plus 1. So by multiplying all of this out, I get to this line here. I then gather up like terms, so I've got a whole n squared plus 2n plus 1. And then I can see that if I factorize that, I get n plus 1 times n plus 1, which is n plus 1 all squared. And because it's whatever n is, and I add 1 to it, but whatever this is, I then square it. So I'm always going to end up with a squared number. Question 18. So scale factor of a minus a half is going to be half the size, half as far away from the centre of enlargement, but because of the minus, it's going to be in the opposite direction to the centre of enlargement. So I think it makes sense just to sort of put in these sunshine rays first of all, just to help you with your answer. It's almost like a bit of a safety net to make sure that your answer is feasible. So I've just popped through lines from each of the corners through my centre of enlargement 0, 0, and I know that all my final points on my revised triangle must sit somewhere on that. So all of these points are going to be half as far away in the opposite direction. So for example, this point here, which is 2, 7, that's going to be, rather than 2, 7, it's going to be, so 2 to the right, 7 up, it's going to be 1 to the left and 3.5 down. this point here, which is presently 2 to the right and 3 up, it's going to be half the size but the opposite direction, so that's going to be 1 to the left, 1.5 down. And this point here, which is 4 to the right, 3 up, is going to be 2 to the left, 1.5 down. So there's my triangle. It is half the size, half as far away, and in the opposite direction. Question 19. So I've got to find an equation for m. So I'm going to be using the y minus y1 formula, and I need to know a point in the line and the gradient of m to be able to do this. So let's kick off looking at the line L, which is perpendicular to m, given that they're sides of the rectangle. So the line L is x plus 2y equals 12. Now I've rearranged that to make y the subject, and therefore I can work out that the gradient of L is minus a half. So how have I done that? I've taken away x from both sides, I've divided by 2, giving me y equals minus a half x plus 6. So the gradient of L, is minus a half. Now the gradient of a perpendicular line, you take the gradient of L and you flip it over, change the sign if you like. So rather than a half, which is 1 over 2, it's now 2 over 1, which is 2. And rather than being negative, it's a plus. So the gradient of m is plus 2. And that makes sense. It's quite steep and it's going upwards, whereas L is quite shallow and going downwards. So I've achieved my first goal. I've worked out the gradient. Question 20. So I've got to find the value of y when x is 45. So what I'm going to do, I'm going to substitute in a couple of these coordinates into this to create a simultaneous equation so I can work out what a and b is. So it makes sense to take a couple of the simpler points. So I'm going to kick off with when x is 0, y equals 3. So substituting that into the equation, I know that 3 equals a cos 0 plus b. Now the cos of 0 is 1. So I've got 3 equaling a plus b, and that's my equation number 1. Now my second equation, I've just chosen to use this 90 and the 1. So I'm substituting back into this when x is 90, y is 1. So 1 equals a times the cos of 90 plus b. Well, the cos of 90 is 0, so I've got 1 equaling b. So if b is 1, going back to this, if b is 1, a must be 2. So I know b is 1, a is 2. So I have my final formula of y equaling 2 cos x plus 1, because a is 2 and b is 1. So I can now use this to work out the value of y when x is 45. So y is 2 lots of cos 45 plus 1. So I need to know what cos 45 is. Now if I use the isosceles triangle with question 21, so to rationalize one of these, I choose to multiply top and bottom by the denominator, but with a change of sign. This is such that when we multiply out, you'll see that the middle two terms in the denominator cancel out because of the change of sign. So this is the key bit. The bit there in red is the key learning point. So I've now just got to multiply out a pair of brackets. So I've got 6 times root 2 plus 6 minus root 16 minus root 8 as the numerator. And on the denominator, I've got root 2 times root 2, which is 2, plus root 2 minus root 2 minus 1. So, as I said earlier, these two middle terms of the denominator will cancel out, leaving me with 2 minus 1 in the denominator, which is just 1. And then in the numerator, root 16 is 4. So I've got 6 taking away 4. 6 take away 4. Root 8 is 2 root 2, so I'm minusing 2 root 2. So my numerator, I'm left with 6 root 2, add 6 minus 4 minus 2 root 2, which is 4 root 2 plus 2. And as I said earlier, the denominator has sort of gone away really because it's just 1. So I'm dividing by 1, so I don't need to list it. So my final answer is 2 plus 4 root 2. Question 22. Now the problem here is that there are 2 possible values of x, and by making different assumptions you can get 2 different scenarios. So picking up the first assumption is easy. So the logical one is to consider these 2 to be similar as is. So we've got triangle ABE being similar to ACD. So BE is parallel to CD, and then this is just a very straightforward 2D similarity question. We've got the length AB being 8, AE being 12, and A to D being 15. So comparing the smaller triangle to the bigger triangle, we've got the common size being the base, so our multiplier is 15 over 12, which is 5 over 4. So we need to work out x, which is a component of AC. So AC is simply 8 times the 5 over 4, which is 10. Because AC is 10 and AB is 8, BC, which is x, has to be 2. So our first solution for x of 2 is very straightforward, I think, and that was with the assumption that ABE is similar to ACD. Now the second scenario and assumption I think is not so straightforward. So what we've got to imagine here is, imagine you cut out this little triangle here and you cut out the bigger triangle ACD, but then you reflected the smaller triangle over it and said the reflection is similar to the bigger triangle. So we're now comparing triangle EBA and saying that's similar to triangle ACD. So EB is still an unknown, BA is still 8, EA is AE, which is 12, and ACD is unchanged. So we've got 8 plus x on the left and 15 on the bottom. Now the problem we have here is, whilst we've still got the common, we can still see we're going from 12 to 15 on the bottom. We don't have, we're then going the 8 to the to this and this to this. We can't work out what x is because we don't know what EB is to multiply across. So you've got to go back to our starting point up here, and I think I think it's easiest to learn that in this scenario, when we've reflected it over, AB times AC, so this length times this length, equals AE times AD. So it's all to do with the similar triangles. So that times that equals that times that. So 8 times 8 plus x equals 12 times 15. And that's what I've done here. So once you got that far, this isn't too bad. So we've got 12 times 15. Let's divide through by 8. So we've got 8 plus x equal 12 times 15 over 8. I've then just cancelled down the 12 and the 8s to 3 and 2. 3 15s are 45 over 2, which is 22.5. So 8 plus x is 22.5. Taking away 8 from both sides, we've got x being 14.5. So our second value for x is 14.5, and that is when you have the assumption that triangle EBA is similar to triangle ACD. Question 23. So we're told that the area of the rectangle is greater than the area of the triangle. Find the set of possible values of x. So the area of the rectangle is greater than the area of the triangle. So the area of the rectangle is obviously base times height. So x minus 1 times 3x minus 2. And that area has got to be greater than the area of the triangle, which is half times base times height, which is half times x times 2x. So multiplying out both sides, we get 3x squared minus 5x plus 2 being greater than x squared. Take away x squared from both sides, we get 2x squared minus 5x plus 2 being greater than 0. Now this factorizes, so you might just be able to factorize this by sort of sight and by trial and error and get straight to 2x minus 1 times x minus 2, or you might need a longer way like I do really. So what I do is I say, right, I'm going to split this middle term into 2, and what are the magic numbers involved there? Well, they multiply to be the 2 times the 2, which is the 4, but they add to be the coefficient of the x, which is the minus 5. What two numbers multiply to make 4 but add to be minus 5? That's minus 1 and minus 4. So I can split this minus 5x down into a minus 1x and a minus 4x. Doesn't matter which way round, I've gone this way. So I've gone from 3 terms to 4 terms. I now fully factorise the first 2 terms, giving me 2x, x minus 2. And then I fully factorise terms 3 and 4, giving me minus 1, x minus 2. And I have this repeated bracket. Now my final pair of brackets is the 2 pieces that are not in the bracket, so 2x minus 1, and then the repeated bracket, which is the x minus 2. Now, to get my range of values, I think a sketch is helpful now. Now I know that this is a positive parabola, a smiley face, and its solutions, its roots are when x equals a half, that makes this first bracket 0, and x being 2, that makes the second bracket 0. And it's a smiley face, as I said before. Now I want all the solutions which are greater than 0, so that's all the solutions above the x-axis, so where x is greater than 2, and theoretically where x is less than a half. Now bear in mind that x is all tied up with the lengths. Now x can't be less than a half because we're then going into negative lengths. So we reject these solutions here, and our final answer are these solutions, so x is greater than 2.